So now we're to find all of the zeros of the function, which means if the function is equal to 0, then solve for x. Because this is a third degree polynomial, it's possible that there's as many as 3 zeros that we're looking for. First of all, I'm going to be looking for a rational zero, which is a real number that is a solution to this equation. And one way to do it is take the leading coefficient, a 2, and find out all of its factors. So a 2 basically has the factors 2 and 1. And a 27 has factors 1, 3, and 9. And of course we need to consider positive and negative cases, but for the moment we'll just deal with the positive cases and see if we can find a solution. And now take one out of here and divide it by one of them out of here. So there are lots of possibilities, because we could have 1 divided by 2, 1 divided by 1, 3 divided by 2, 3 divided by 1, etc. So to save a little bit of time, I'm going to take a look at the graph of the function. And there's a real 0 or x-intercept right there. It looks like it's at 3/2 or 1.5. So that would come from this one divided by that. So x equals 3 divided by 2 is one of the zeros. And now, if this is one of the zeros, we can use synthetic division to divide that into this polynomial. And if it really is one of the zeros, the remainder will be 0. Let's look at what that's saying. So 12. If I know that 12 is one of the, if 4 is one of the factors of 12, then when I divide a 12 by a 4, it's going to divide evenly and just give me a 3. But there's no remainder. The same type of idea here. If this really is one of the zeros, and I'm pretty sure that it is, trace is 3/2 correct. Yes, that is one of the zeros. Then it will divide evenly into the polynomial when we use synthetic division. So let's do that. So use the coefficients from this polynomial, a 2, -3, an 18, and a -27. And out here goes what x is equal to, 3/2. Start by carrying down a 2, and then the idea is multiply and add. So multiplying this way are going to cancel the 2's, leaving a 3. Added to that's going to be a 0. And then do the same thing here, 3/2 times 0, add it to 18. Next is the 3/2 times 18, which is going to be, well, the 2 dividing into this is going to be a 9. That 9 times the 3 is going to be 27. So adding it to this, sure enough, the remainder is 0, just as it was supposed to be. That's good news. So the original problem was an x cubed. We just divided out an x, so we're left with x squared. 2x squared plus 0 for x plus 18. And then from this polynomial we need to find the other two zeros. So the first one was a rational zero, a fraction, and it looks like the next two are going to be complex zeros. So to solve for x, we can subtract 18 from both sides, divide by 2, and then take the square root. So we're going to have positive, negative, the square root of negative 9, which is a complex or imaginary number, pair of numbers. So it's going to be positive, negative 3i. If you take a look at the graph, you're not going to see 3i because this uses only real numbers, so only the real number solutions are going to show up on my graphing calculator. The imaginary solutions are not there. But now we've found all of them, plus and minus 3i, and x is equal to 3/2.